Hello there, and welcome to the Sleepy Sky. I'm glad you arrived here tonight, at this quiet edge of the day where thoughts begin to soften and the noise of the world slowly fades. Maybe your hours were heavy, full of small demands and unfinished tasks. Maybe your day was light but busy, with conversations still echoing softly in your mind. Whatever it held, you do not have to carry it now. You can set it down for a while, as if you were placing a bag on the floor beside your bed. Nothing inside it needs your attention in this moment. Your only task is to breathe, to listen, and to let the night unfold around you. As the night unfolds around you, the room itself becomes part of the story. The air settles into a cooler, quieter layer against your skin. Shadows gather softly in the corners. Outside, if you listen closely, there might be the distant hush of tires on a road, or perhaps the faint rustle of leaves in a slow-moving breeze. Even if you hear nothing at all, that silence has its own texture, soft and steady, like a dark blanket drawn gently over the sky. Let that quiet blanket reach you too. Let your jaw loosen, your shoulders drift a little lower, your breath spill out in a calmer way. It's perfectly fine to let the day fall apart into small, harmless pieces of memory now. Somewhere above the roof, above the cloud line, above the thin blue shell of air that wraps our world, the universe is stretching out in every direction. It does not hurry, it does not strain. Astronomers estimate that the observable universe spans about 93 billion light-years across, a distance so large that numbers become more like suggestions than measures. Yet, in all that reach and distance, most of the cosmos is not blazing with light. Most of it is cool, dark, and slow, not empty, simply quiet. In that dark, a soft glow lingers, a leftover warmth from when everything was closer together and much younger. That leftover warmth is called the cosmic microwave background, a gentle sea of radiation that fills space in every direction. Long ago, when the universe was dense and bright, light could not travel freely. Particles bumped and scattered it, turning it back on itself again and again. As space expanded and cooled, that light finally slipped free and began to drift. It has been drifting ever since, stretched into longer, softer waves by the growth of space itself. Now, it hums as a faint microwave glow, just a few degrees above absolute zero, like an almost forgotten ember in an enormous hearth. You can imagine it as a quiet, invisible mist of warmth, still present after billions of years. After billions of years, that ancient light still passes through you, through the walls, through the calm air around your bed. Sensitive instruments can see it clearly, mapping tiny variations that once guided how galaxies formed and clusters gathered. But to you right now, it can simply be a comforting thought, a reminder that the universe has been cooling and calming for a very long time. The fiery beginning has relaxed into something slower, gentler, more spacious. You can relax with it. You can let your own thoughts cool, like metal taken from the forge and left to rest on soft, dark stone. Nothing in this moment demands heat from you. You have permission to be soft now, far away, in that great stretching quiet. Tiny particles of hydrogen float between galaxies. Hydrogen is the simplest atom, one proton and one electron, the basic note in the universe's long song. In huge, dim clouds, these atoms drift past each other, sometimes colliding, sometimes passing by without a sound. Over time, under the steady pull of gravity, they gather. Gently, grain by grain, they fall toward regions where their combined weight grows heavier, Gravity does not shout, it whispers, pulling matter into slow, spiraling paths, shaping structure from almost nothing. In this way, galaxies form, not all at once, but through patient accumulation. Through patient accumulation, stars are born. Starlight does not simply appear, it emerges. In dense knots at the hearts of those clouds, gas becomes so crowded that its atoms press tightly together, heating the core from within. When the conditions are just right, not too hot, not too cold, not too thin, nuclear fusion begins. Hydrogen fuses into helium, releasing energy in a calm, continuous flow. That energy struggles outward, bouncing from particle to particle until it reaches the surface of the star and slips into space as light. What looks to us like a steady glow is the result of countless small processes happening in a balanced rhythm. Nothing about it is rushed. You can let that balanced rhythm reach you. You might feel your breath move in its own orbit, rising and falling in slow, regular waves. You might notice the weight of your body resting against the bed, supported without question, held by the simple firmness of the mattress beneath you. The universe holds stars and galaxies in its vast dark web. Your room holds you in a quieter, smaller way, but the feeling is similar, supported, cradled, gently contained. It's perfectly all right to lean into that feeling. Far beyond the clouds and city lights, starlight begins a long journey across space. Photons, tiny packets of light, slip away from the surface of a star and travel outward, not bending or slowing on their own, moving in straight paths unless something nudges them. On their way, they may pass through wisps of dust, through cool gas, through the faint edges of distant nebulae. Dust grains are small, but not insignificant. They scatter blue light more easily than red, sending those shorter waves off to the side and allowing longer, warmer tones to continue forward. Over long distances, this subtle filtering makes starlight look softer, more amber, more gentle. More gentle light reaches us this way, having passed through those drifting curtains of dust. You can picture a pale red star shining through a hazy veil, its brightness muted into a quiet glow. Some beams never reach any eye at all. They travel on, unbothered, spreading thinner as they go, cooling as the universe continues to expand. Others are gathered by the mirror of a telescope, focused onto a sensor, turned into data. Some slip through your window when the night is clear and settle onto your eyelids, even when they are closed. You may not see them, but they arrive all the same, tiny reminders that you exist within a field of light that began long before you were born. It is easy, in the rush of a day, to feel small in a way that feels sharp or lonely. But here, in this slow, cosmic frame, smallness can feel different. In a galaxy of hundreds of billions of stars, on a planet that moves through space at great speed while you rest, there is room to let go of all the small expectations you carry. The universe is vast and mostly quiet. You are a calm moment within that quiet. You are not separate from it. You are one more gentle pattern in a sky full of patterns. You can simply belong here. Think of a spiral galaxy turning in the dark. Its arms are filled with stars, gas and dust, all moving together in slow, shared orbits. From afar, the whole structure looks still, a glowing pinwheel frozen against the backdrop of space. Up close, every part is in motion, but the motion is smooth and predictable, like a long, slow breath. Our Milky Way is one such galaxy, and our solar system rides along one of its arms, circling the galactic centre in a journey that takes hundreds of millions of years. Entire species rise and fall, entire histories unfold, while our star completes just one lap. There is no pressure to hurry in a cycle like that. In a cycle like that, even change feels steady. Stars are born in clouds, live their long lives, then release their material back into space when they die. Some end in quiet ways, slowly fading into white dwarfs that cool over trillions of years. Others end more dramatically, seeding space with heavy elements. Those elements later become part of new clouds, new stars, new planets, and eventually living beings who look up at the sky and wonder. The calcium in your bones, the iron in your blood, the oxygen you draw in now. Each of these parts of you was once held inside a star. To rest tonight is to let that star stuff pause, just for a while, in the shape of your body. Let that thought soften you. Imagine the room again, the soft edges of familiar shapes. Perhaps there is a faint line of streetlight slipping under a curtain, or a small glow from a clock or charger. These tiny lights echo distant stars in their own quiet way. Small signals in a larger darkness. A gentle scent might linger, from clean sheets or a nearby plant. The fabric beneath your hand may feel smooth and cool, or warm and worn. All of these small sensations anchor you here, on this one planet, under this one part of the sky, while your mind drifts outward into the wider universe. You are both here and there at once, grounded in your room, and floating among galaxies in thought. Floating among galaxies in thought, you may notice how the mind likes to wander, how it moves from one image to another in slow arcs once the day has loosened its grip. This wandering is natural. Just as particles drift in space until gravity gently folds them into new shapes, your attention can drift through memories and ideas until it settles somewhere softer. When it lands on something that feels heavy, you do not have to push it away. You can simply let it sit for a moment, then let it slide past like a cloud moving calmly across a pale night sky. You do not need to follow it. You can watch it go. In the deepest parts of space that we can see, galaxies gather into clusters and superclusters, separated by wide stretches of darkness. These structures are shaped by invisible matter, by gravity, by the slow expansion of the universe itself. There is a web-like pattern on the larger scales, bright threads of galaxies, dark gaps in between, all formed over billions of years by patient forces. When you look at maps of this cosmic web, you see something intricate yet peaceful. There is no sign of rushing there, no sign of panic, only patterns that have had an immense amount of time to unfold. You too are allowed to unfold slowly. There is no requirement that you solve anything tonight, or decide anything, or perfect anything. The universe has taken nearly 14 billion years to arrive at this quiet moment, with you lying here, listening. It can give you a few hours to rest. The same physics that guides starlight and shapes galaxies also governs the gentle rise and fall of your chest. Your lungs expand and contract. Blood moves in slow circuits. Neurons send signals that gradually grow fewer and softer as you approach sleep. Inside you, countless tiny processes adjust, heal, and restore without any need for your conscious help. You're allowed to trust that inner work. If your mind is still active, that is all right. Thoughts may try to pull you back into the day, into tomorrow, into imagined futures. You can greet each one with a kind nod and let it drift by, as if you were watching small boats on a wide, slow river. No boat needs to be chased. No thought needs to be held. In the distance, the river merges with the sea. On the larger scales, the sea merges with the dark of space. Everything flows into something wider and quieter. Something wider and quieter holds you now, above you, unseen. The thin layer of atmosphere wraps the Earth in a soft shell. Higher still, satellites circle the planet, their paths smooth and predictable. Beyond them, the moon drifts in its familiar orbit, showing the same face to us, its surface silvery and still. Further out, planets move around the sun, each at its own pace, each held by the same gentle law of gravity. Past them, comets wander in long stretched-out ellipses, their icy cores sleeping for centuries at a time. And farther still, beyond the reach of our current spacecraft, the sun's influence fades and interstellar space begins. In that vastness, the ancient microwave glow continues to hum, as steady as a heartbeat. You're resting inside this layered calm. The cosmos, with all its scale and structure, might sound overwhelming at first. Yet the more you linger with it, the more it reveals its slow nature. Every light year, every orbit, every rotation is measured not in seconds, but in long, patient spans. Galaxies do not start and stop. They glide. Stars do not flicker in panic. They shine steadily, then gently dim. The universe has no alarm clock. No schedule presses upon its quiet expanse. It simply continues, in motion yet at rest, full of energy yet suffused with stillness. In that stillness there is a lesson. Tonight you are allowed to step into the same slow rhythm. You can let your breath match the pace of a distant star, steady and unhurried. You can let your thoughts stretch out and thin, like light travelling across the depths of space, growing softer as they move. You do not have to do anything special to join this rhythm. You are already part of it, simply by existing here, simply by lying down and allowing the night to fold gently around you. As this cosmic calm settles deeper into you, the room may feel a little quieter, the air a little heavier with rest. Your eyelids may feel warm and pleasantly heavy, your limbs loose and still. There is nothing you need to fix. There is nowhere else you need to be. The universe, in all its vastness, continues its slow, graceful motion, and you are one resting moment inside that motion, small, peaceful, and complete. And as this cosmic stillness opens around you, we begin to notice the light that travels through it, the ancient glow that has been on its way for so very long, light that will guide us gently into the next part of our journey, where starlight itself becomes a soft companion in the dark. In this simple awareness, a quiet truth rests. When we understand how calmly the universe moves, it becomes easier to let our own hearts move more quietly too. Night settles over the planet in slow layers, one city after another slipping into shadow while others turn toward the sun. Above the shifting line between day and darkness, the sky holds its steady form. Stars emerge where clouds step aside, small pale points scattered across a canvas of deepening blue. For anyone who looks up, each star is a simple brightness. Yet behind each point lies a long story of distance and time, of patient travel through quiet space. Quiet space receives that light without hurry. A photon leaves the surface of a distant star, pushed outward by the energy of fusion at its core. It slides past the star's atmosphere, past drifting fragments of rock, past pale rings of unseen planets. Then the path opens, and the photon begins its long glide through the darkness between suns. There is no friction to slow it, No wind to buffet it, only the smooth geometry of space itself. It keeps going, following the straightest line that the curved fabric of gravity will allow. The curved fabric of gravity gently shapes the journey. Massive objects, stars, planets, clusters, bend the space around them, like soft impressions in an invisible sheet. Light follows those bends, not because it chooses to, but because that is where straight now lies. Sometimes a photon passes near a heavy object and its path is bent, its straight line softly redirected. Astronomers call this gravitational lensing. To the light, there is no sudden jolt, only a subtle change in direction, so gentle that it feels like part of the natural flow. In that natural flow, distance stops feeling like an obstacle and becomes a kind of quiet story. Many of the stars visible in a clear night sky are dozens, hundreds, or thousands of light years away. Their photons have been travelling all that time, crossing vast regions where almost nothing else resides. A light year is the distance light covers in a year of steady motion, and each year the photon continues, unweary and unchanged in speed. It passes through thin wisps of gas, through dust that softens its colour, through environments that never notice its presence. Still it moves, slow in feeling yet swift in fact, faithful to the path it has begun. A soft sense of safety rests in this simple reliability. The laws that guide each ray of light do not waver or forget themselves. They hold calm and constant across the entire expanse. Dust scattered through space plays a quiet role in this journey. Tiny grains made of carbon, silicates, and other elements forged in older stars float in delicate clouds between and around stellar systems. When light from a star passes through such a dust cloud, shorter blue wavelengths are scattered more easily than longer red ones. The blue light ricochets, sent sideways into new directions, while the red light passes on more directly. Over great distances, this bias shifts the colour that eventually arrives, turning once white starlight into a warmer amber tone. That warmer amber tone gives the night its gentle character. Glowing regions near the plane of the Milky Way often carry a soft golden cast, the result of countless photons filtered through dust-laced space. Some star clusters shine with a faint reddish glow, signalling their age and the dominance of cooler, longer-lived stars. The halo of a galaxy may appear slightly bluer, where younger, hotter stars reside. These subtle differences paint the sky with quiet gradients, not harsh contrasts. To the eye, they remain understated, more felt than seen, a faint layering of warmth over darkness. In this layering of warmth, the cosmos reveals its patient artistry. Nothing in these colours is rushed. Stars that burn with cooler, redder light often live longer than their hotter blue counterparts. Red dwarf stars can exist for trillions of years, steadily fusing hydrogen into helium at a measured pace. Their light is not showy. It does not blaze across the sky in dramatic bursts. It glows with a steady, deep calm like an ember that never quite burns out. Blue giants, by contrast, burn fiercely and briefly, exhausting their fuel in a fraction of that time. The universe holds both kinds of stars, but over the longest spans the gentle red light remains. Long spans of time allow the universe to relax into shapes that feel stable. Star clusters slowly drift apart, galaxies merge in slow embraces, and light from faraway events continues to stream outward, long after the events themselves have ended. When a star explodes in a distant galaxy, its brief burst of brightness may fade quickly at the source. Yet the light from that moment continues travelling for millions of years. Somewhere, far down that path, it may one day meet an instrument, a telescope mirror, or a passing world. The explosion is over. Yet its message moves on, transformed from drama into a simple faint shimmer. In the soft echo of those faint shimmers, the universe feels deeply peaceful. The concept of redshift emerges from this slow expansion and patient motion. As space itself stretches over time, the light that travels through it is stretched as well. Waves that began shorter and more energetic become longer, cooler, and more gentle. What might have started as visible light, bright and sharp, can be stretched into the infrared or even into microwave wavelengths, invisible to human eyes, yet still part of the same original pulse. It is as if the universe has taken a bright sound and lowered its pitch, turning a sharp note into a low, restful hum. That low, restful hum is present in the cosmic microwave background, the ancient light released when the early universe cooled enough for photons to move freely. Once brilliant and intense, that radiation has been stretched across billions of years into a soft glow that pervades all of space. Its temperature now is a little under 3 degrees above absolute zero, so cold that only sensitive instruments can detect it. Yet it fills every direction, like a quiet memory that the universe carries everywhere it goes. Everywhere it goes, light leaves traces of its journey. Spectra, the rainbows of colour produced when light is spread out by a prism or diffraction grating, show thin lines where atoms absorb or emit particular wavelengths. These lines act as fingerprints, telling of hydrogen, helium, oxygen, and heavier elements. When those lines are shifted toward the red end of the spectrum, it indicates that the source is moving away or that space between has expanded. In this way, astronomers can listen to the history etched into starlight, reading speed, distance, and motion from subtle shifts in colour. It is a kind of quiet conversation between matter and observation, carried on across distances too large to imagine clearly. In that quiet conversation, the cosmos explains itself without urgency. On clear, dark nights, the Milky Way stretches overhead as a pale band. To the unaided eye, it appears as milky haze, a softly glowing river of light flowing from one horizon to the other. Through binoculars or a small telescope, individual stars emerge from that haze, each one a sun in its own right, each sending out its own stream of photons. Dust lanes cut across the band like dark rivers, obscuring parts of the glow. Behind them, more stars wait, their light temporarily veiled, still moving toward observers who do not yet see them. Veiled or visible, the motion of light remains the same. Photons travel in straight lines at a constant speed, unaffected by the passage of time in the way material objects are. They do not slow down as they age. They do not tire. They simply move, carrying information from one point in the cosmos to another. When they encounter matter, they may be absorbed, scattered, or transformed, but until that moment, they remain focused on their one simple task: to go on. There is a deep reassurance in this simplicity, a sense that some things continue reliably, regardless of what happens on smaller scales. Some things continue reliably, and that reliability forms a soft foundation beneath all the change. Consider a photon leaving a star on the far side of the galaxy. It begins near the crowded centre, where stars are packed more tightly, and the background glow is rich and dense. It threads its way through regions of higher gravity, slipping past clusters, grazing the edges of molecular clouds. As it moves outward, it passes through the spiral arms, through regions where new stars are being born, where older stars are cooling. Eventually, it reaches the more open outskirts of the galactic disk and continues into intergalactic space, where the density of matter drops further and further. It might travel for hundreds of millions of years before it ever encounters anything substantial. On some distant world, that single photon may arrive at last. Perhaps it strikes a pale rock, warming it by an almost immeasurable amount. Perhaps it touches the surface of a frozen moon, reflecting off ice crystals before vanishing into the chill around them. Or perhaps it encounters a sensor built by an intelligent species, becoming one tiny part of a larger picture, an image of a galaxy, a spectrum of a star, a data point in a long study. In each case, the journey ends quietly, without fanfare, the long crossing of space concluding in an instant of contact. There is calm in knowing that even the longest journeys resolve into simple moments. The glow of the night sky is not only starlight. Gas clouds excited by radiation emit their own faint colours. Nebulae can shine with soft reds from hydrogen, delicate greens from doubly ionized oxygen, and other subtle hues. Scattered light from distant stars mixes with these emissions, creating regions of blended colour. To the eye, these differences may appear as slight tints, but to instruments, they are clear signatures. Each wavelength tells of temperature, density, and composition, yet together they feel like a single, continuous wash of light. In that continuous wash, the cosmos seems to breathe slowly. Bright regions inhale, glowing where energy is concentrated. Dark regions exhale, cooling and dimming. Over time, energy moves from hot, dense regions into wider, cooler spaces. Stars distribute their light into the darkness around them. Galaxies share their glow with the thin medium between. Gradually, the universe grows more even, more uniform, more quiet. This long slide toward equilibrium mirrors the way a busy mind can, given space and patience, settle into a calmer state, thoughts spreading out and losing their sharp edges. Thoughts can lose their sharp edges just as light loses its intensity with distance, becoming softer and more diffuse. When starlight passes through a planet's atmosphere, new interactions shape its path. Molecules in the air scatter shorter wavelengths more readily, which is why skies can appear blue during the day on worlds like Earth. When the sun is low, that blue light is scattered away from the direct line of sight, leaving longer red and orange wavelengths to dominate, painting sunsets and sunrises in warm tones. During the night, residual scattering, air glow, and faint reflections from dust and clouds soften the darkness, giving it a textured depth rather than a hard void. Above that layered atmosphere, the stars continue to shine with their own filtered hues. Filtered hues remind observers that light is always in relationship with its surroundings. It does not exist in isolation. Dust, gas, magnetic fields, and expanding space all leave their marks on its colour and direction. Yet even after all these interactions, enough information remains for those who study light to reconstruct the histories of distant objects. A subtle line in a spectrum may reveal the presence of a specific element. A small shift in colour may show how quickly a star is moving relative to an observer. Light is both delicate and durable at once, easily altered, yet faithful in what it carries. Delicate and durable at once, the glow of the cosmos reflects a balance between change and constancy. In the very distant universe, The most remote galaxies appear as tiny, faint smudges in deep sky images. Their light has taken billions of years to reach the detectors that capture it. During that time, the galaxies themselves have continued to evolve, forming new stars, merging with others, changing shape. The light that arrives now is an image of how they once were, not of how they are. To look out into space is to look back through time, seeing a younger universe layered beneath the present one. This gentle time delay is built into the structure of reality. A gentle time delay is built into human perception as well. Signals from the eyes travel along nerves to the brain, where they are processed. The picture each mind holds of the world is always slightly in the past, even if only by fractions of a second. On the scale of daily life, this delay is negligible. On the scale of galaxies, it is profound. Yet in both cases, reality is experienced as continuous and stable, a flowing present that contains traces of many past moments layered together. The night sky embodies this layering. Nearby stars shine with fairly recent light, while faraway galaxies contribute photons that began their journey when life on Earth was still young. Within this layered, slow glow, the cosmos appears gentle, even when its underlying processes are complex. Ancient light, stretched and softened by time, carries no urgency. It does not insist on being noticed. It arrives whether or not anyone is watching, whether or not any telescope is pointed its way. When it does meet an eye, or a mirror, or a sensor, it becomes part of a story. That story can be told with equations and models, or with metaphors and quiet reflections. Either way, the essence remains the same. Starlight is patience made visible, the record of vast distances crossed without haste. In that realization lies a simple, calming thought. If light can travel for ages through the darkness, changed yet continuous, then there is room for lives and hearts and minds to move more slowly too. The universe does not demand constant brightness. It allows for dimming, for softening, for long stretches of quiet in between brief flares of energy. The warm amber glow that reaches this small world tonight is part of that broader permission, a sign that even in a universe born from fire, gentleness endures. And as this softened glow rests across the sky, the path opens toward the great rivers of stars that shape it, guiding the story onward into the slow, spiral drift of the galaxy itself, where motion and stillness fold into one calm design. The night deepens, and the sky gathers itself into a wide, gentle curve. From horizon to horizon, the Milky Way stretches like a pale river, soft and luminous, flowing across the darkness with a quiet grace. At first glance it seems still, as if painted in place. But within that faint glow lies motion on a scale so vast that it moves beyond ordinary perception. Nothing there is fixed. Every point of light drifts. Every cloud of dust glides. Every star follows its long, spiraling path. Its long, spiraling path carries our solar system as well, though the motion is too slow to feel. The galaxy's rotation is steady and deliberate, completing one full turn only once every hundreds of millions of years. To a human life, that duration feels endless, but to the cosmos, it is simply a cycle, unhurried and consistent. Our star, with its planets and icy outskirts, rides along one of the Milky Way's arms like a small boat drifting in a vast current. The current does not rush. It holds everything in a balanced flow, guided by the gravity of countless stars gathered in the central bulge. In that balanced flow, stars move with a rhythmic calm. Some travel faster, some slower, depending on their distance from the centre. Yet together, they form a pattern that has endured for ages. Gravity shapes the path of each star gently, not forcing but guiding, bending their routes into broad curves. This collective motion creates the familiar spiral structure, even though no single star knows the pattern it helps to trace. To the eye, these spiral arms appear solid, like great glowing rivers. In truth, they are regions where stars, gas, and dust are more concentrated, places where matter drifts inward and outward in a continuous cycle. A continuous cycle is at work in the star-forming clouds within those arms. These clouds, vast and dark, drift slowly through space, composed of hydrogen, helium, and tiny grains of dust. In the quiet interior of such a cloud, random motion gradually gives way to cohesion. Pockets of gas become denser, temperature drops, gravity begins its quiet pull, gathering the particle more tightly. Over time, these regions compress into cores where the pressure grows. When the conditions become just right, fusion ignites and a new star is born. From a distance, these nurseries glow in soft reds and purples, illuminated by the newborn stars within. Within those glowing regions, the light is gentle, filtered through dust and cooled by distance. Nebulae near the core of the galaxy shine brightly, but by the time their light reaches the outskirts, it has softened into a diffused glow. That glow becomes part of the Milky Way's shimmering band, blending with the light of older stars. The result is a delicate mixture of hues: pale blues from hot young stars, warm yellows from aging suns, faint reds from cooler, more stable stars. From Earth, these differences blur into a soft, luminous haze that arcs overhead, a reminder of the galaxy's living structure. Its living structure is ancient but still evolving. Near the centre lies a dense cluster of stars orbiting a massive black hole, quietly anchoring the galaxy's motion. The black hole itself does not consume everything around it. Instead, it provides a gravitational focus, a deep well that shapes the paths of nearby stars. They move swiftly there, tracing tight orbits. But as one moves outward from the centre, the density decreases and the motion becomes more relaxed. Dust lanes curl through these regions, weaving shadows across the bright central glow. Each lane is a stream of particles drifting slowly, absorbing light and revealing the galaxy's layered complexity. In that layered complexity, there is a calm rhythm. Hydrogen clouds cool and contract, stars ignite and age, their light fills the spiral arms. Eventually they release their material back into space, feeding new clouds, restarting the cycle. On the scale of a human life, these steps seem unchanging. On the scale of centuries, generations might witness slightly different patterns of stars, but the change is subtle. Over millennia, the adjustments grow more apparent. Over millions of years, the arms twist differently. Over billions of years, the entire structure shifts. Yet through all this, the galaxy maintains a serene, overarching symmetry, as if guided by an internal stillness. Internal stillness is present even in the movement between stars. Most of the Milky Way is made not of brilliant suns, but of dark, open space. In these stretches, the density of matter is low. Particles drift for vast distances before encountering anything substantial. Magnetic fields thread through this emptiness, shaping the paths of charged particles. Cosmic rays pass silently, their origins scattered across the galaxy. Through it all, light travels, its colour shaped by what it encounters. The quiet between stars is not empty, it is spacious. a field of possibility where faint processes unfold without sound. Without sound, these processes remind us that much of the universe exists beyond the reach of human senses. Waves of light, radio signals and particles flow across the galaxy unnoticed until they reach instruments sensitive enough to detect them. To think of these invisible rivers swirling around and through the Milky Way is to understand that we live in a sea of unseen motion. The galaxy is not a static picture. It is a slow-moving, interconnected dance, each part influencing the others in ways both subtle and profound. Subtle and profound forces shape the outer regions of the Milky Way as well. Surrounding the galactic disk is a halo of stars and globular clusters, ancient groups containing some of the oldest suns in the galaxy. These clusters orbit the galactic center in elongated paths passing above and below the disk, tracing routes that can take hundreds of millions of years to complete. Their stars shine with a faded brilliance, their ages marked by a shift toward redder hues. These ancient suns act like quiet witnesses to the galaxy's long history, carrying within them the chemical signatures of early cosmic times. Early cosmic times were filled with rapid formation, intense radiation, and collisions between young galaxies. Over billions of years, the Milky Way grew by merging with smaller galaxies, absorbing their stars into its structure. Some of these captured stars now form streams across the sky, thin trails left behind by the remnants of those swallowed systems. These streams arc gracefully through the halo, their stars continuing to move as a group long after their parent galaxy was torn apart. They represent the slow, persistent integration that shapes large cosmic structures, turning once separated systems into a unified whole. A unified whole emerges from these streams and mergers, from the steady rotation and the quiet energy of stars. The Milky Way becomes not just a place, but a pattern, a soft spiral etched across space. Observed from afar, it might resemble a glowing whirlpool of pale light, its arms stretching gently outward. But from within, from our small vantage point inside one of those arms, it appears as delicate threads of brightness woven into the night. The scale makes the difference. What is immense becomes intimate when seen from the inside. From the inside, our solar system feels small but centered. We orbit the galactic center at great speed, yet the motion feels non-existent in everyday life. The Earth turns beneath us, the Moon circles the Earth, the planets loop around the Sun, all while the Sun itself travels through space. These nested motions create a layered sense of belonging, as though each system supports the others in a quiet cascade. Everything moves, yet everything feels stable. The galaxy carries us without effort. Without effort, stars drift along their orbits, some in crowded regions, some in isolation. Many stars travel with companions, binary or multiple systems that revolve around one another in elegant arcs. Others drift alone, surrounded only by their planets and the dust left from their formation. In either case, their motion is slow, steady, and predictable. Gravity shapes their paths with gentle firmness, offering no surprises. The stars are patient travelers, content to follow their routes for millions or billions of years. Millions or billions of years create room for stories beyond imagining. Somewhere in the galaxy, a star might be completing its first orbit since its formation. Elsewhere, another might be nearing its last. Some stars are so young that their light has only recently reached space. Others are so old that they have begun to cool, shrinking down into white dwarfs that will eventually fade into darkness. All of these stages unfold in silence, with no hurry, with no need for attention or acknowledgement. In that silence, the galaxy expresses its calm nature. Even the most dynamic events, supernova explosions, stellar winds, the birth of new stars, occur against a backdrop of vast, slow-moving equilibrium. The arms rotate, the halo drifts, the clusters complete their orbits. It is a grand choreography, but not one that demands observation. It continues regardless, steady and unbroken. Steady and unbroken, the Milky Way offers a sense of continuity that can anchor the mind. When days feel crowded or thoughts spiral too quickly, considering the galaxy's long arcs can ease the pace of the inner world. Every star moves in a manner that suggests patience. Every cloud of gas reminds us that formation takes time. Every spiral arm hints that even immense structures find their shape in gentle curves. Gentle curves fill the sky tonight, and their quiet presence invites rest. The Milky Way does not rush through its cycle. It drifts, it glows, it waits. Within that waiting there is a soft truth. Nothing in the universe exists outside of motion, yet nothing is required to move quickly. The galaxy's slow dance continues whether anyone watches or not. And as this spiral opens before the imagination, its arms stretching outward into the soft dark, we drift with it, carried toward the quieter spaces between the stars, where the vast, cool openness of the interstellar medium waits with a calm that deepens like the breath before sleep. The spiral arms of the Milky Way stretch outward in gentle sweeps, their glowing threads fading softly at the edges. Between these arms there is a deeper quiet, a wide, pale darkness where stars grow fewer and the spaces between them widen into calm, open expanses. This is interstellar space, a region that at first seems empty, yet holds a delicate and intricate stillness. Here, dust grains drift alone for centuries. Atoms of hydrogen pass one another with long, unhurried gaps in between. Light itself slows in feeling, not in speed, spreading thinner and gentler as it moves through the silence. Through the silence, particles continue their slow journeys. Even in the most remote regions of the galaxy, matter is never fully absent. A few atoms might reside in a cubic centimetre of space, far fewer than in any air you've ever breathed, but they exist all the same. They drift without contact, rarely colliding, feeling the faint pull of distant gravities. These particles, sparse and quiet, create a medium that stretches between stars. Astronomers call it the interstellar medium. To the mind, it may feel like a vast, soft vacuum. In truth, it is a gentle ocean of the thinnest material, lying between the bright points of starlight. The thinnest material carries the faintest whispers of structure. Hydrogen atoms align with magnetic fields, creating subtle patterns across vast distances. Dust grains absorb light and glow faintly in infrared wavelengths. Cosmic rays, high-energy particles from supernovae or active stars, travel through this medium, moving at incredible speeds, while the medium itself remains still. The contrast creates a sense of layered motion, like fast currents beneath an ocean that looks calm on the surface. Yet even these fast-moving particles do not disturb the quiet. They pass without sound, without ripple, unnoticed by the soft dust surrounding them. Unnoticed, too, is the faint hum of microwave background radiation, the cooling remnant of the early universe, which permeates all of space. In interstellar regions, far from the warmth of stars, this background glow becomes the primary source of temperature. It cools the environment to just a few degrees above absolute zero. At such temperatures, atoms move sluggishly. Molecules form and break apart in slow cycles. Chemical reactions unfold at a languid pace, giving cloud formation and dust accumulation a deep stillness. A deep stillness like this is rare on Earth, where motion and warmth animate every surface. Out here, time seems to thicken. Processes that would unfold quickly in a warm environment take thousands or millions of years. A dust grain might slowly accumulate icy coatings, oxygen, carbon monoxide, nitrogen, layer by thin layer, like frost on a window forming in slow spirals. When a nearby star eventually warms the region, these ices evaporate, releasing molecules that drift and mix with others. The cycle continues, measured not by hours or days, but by eons. By eons, the interstellar medium shifts between phases. Sometimes it's cold and dense, forming molecular clouds where stars may someday be born. Sometimes it is warm and diffuse, stretched thin by stellar winds and radiation. Supernova explosions push shock waves through this medium, compressing some regions and dispersing others. Yet, even these energetic events unfold in slow motion across cosmic scales. A supernova blast wave may take tens of thousands of years to pass through a region, its influence felt not as sudden force, but as a gradual reshaping. A gradual reshaping happens everywhere in interstellar space. Dust grains collide and stick together, forming slightly larger particles. Gas clouds drift into new shapes as gravity pulls gently on them. Magnetic fields bend and twist, guiding charged particles along invisible paths. The result is a landscape of softly changing forms, wisps of gas curling into filaments, patches of dust settling into dim knots, wide expanses clearing into low-density voids. None of these changes is abrupt. They occur like breath spread across millennia, slow and steady. Slow and steady becomes the natural rhythm here. Without sound, without wind, without sudden transitions, the interstellar medium feels like a place where time itself rests. In the absence of pressure from nearby stars, darkness becomes textured rather than empty. Shades of blue, grey, and violet may appear faintly in images taken with sensitive instruments, revealing molecular clouds shaped like drifting smoke. In visible light, these clouds often appear as voids, dark patches blocking the stars behind them. Yet in infrared they glow softly, warmed by the faint radiation passing through. Through these quiet clouds, starlight filters gently. Each grain of dust absorbs and re-radiates light, turning bright beams into muted glows. This process reddens the light, giving certain regions of the sky a warm tint. The reddening is subtle but persistent, a sign that even in emptiness, interactions shape the path of light across the galaxy. When astronomers map these patterns, they uncover the delicate architecture of interstellar space, its strands, filaments, and folds. Its strands and folds act like the veins of the galaxy. They carry gas from one region to another, feeding star-forming clouds and dispersing remnants of long-dead stars. These veins shift over time, forming new routes for material to travel. In some places, dust thickens enough to block entire sections of the star field from view. In others, gaps open, allowing clear sight into deeper regions of the galaxy. The result is a sky textured with both illumination and shadow, brightness and dimness, clarity and veil. Clarity and veil exist together, creating a sense of mystery without urgency. The darkness between stars is not threatening, it is simply quiet. It is a silence so complete that sound has no meaning. It is a cold so deep that movement slows to the gentlest crawl. It is a space so open that any single atom may travel for years without touching another. Yet within that openness lies stability, a calm, steady foundation that supports the galaxy's larger structure. A calm, steady foundation forms even where stellar winds blow outward. Stars, especially young and hot ones, emit streams of charged particles. These winds carve out cavities in the interstellar medium, creating bubbles of lower density. Where multiple stars exist in a cluster, their winds merge, forming larger cavities. The edges of these bubbles press against surrounding gas, compressing it into shells. Over long spans, these shells may accumulate enough material to begin forming new stars. Even the disruptive force of a stellar wind is part of a slow cycle that brings forth new life in the galaxy. New life emerges where collapse finally overcomes pressure. In the densest pockets of molecular clouds, gravity gathers gas until it can no longer resist. The collapse begins slowly, at first almost imperceptible. Over time, the core grows denser and warmer. Eventually, nuclear fusion ignites, and a new star forms. It shines softly at first, hidden within the cloud that created it. Only after the surrounding material is pushed away does the star become visible. Such births are rare events in any given human lifespan, yet they occur continuously across the galaxy, each one a quiet testament to the patient cycles of interstellar space. The patient cycles continue as stars age and eventually shed their outer layers. Red giants blow off shells of gas that expand outward, merging with the interstellar medium. Supernovae scatter heavy elements, enriching the clouds around them with the material needed to form planets and living worlds. White dwarfs cool into dim embers that remain as silent witnesses to all that has passed. Each stage contributes to the ongoing renewal of the medium. Ongoing renewal gives interstellar space a sense of purpose that is gentle and enduring. Even though it appears dark and empty, it is the birthplace of stars, the repository of cosmic memory, the silent corridor through which light and matter travel. It is a bridge between bright places, a resting point in the galaxy's grand design. Nothing stirs loudly here, yet everything participates in the slow unfolding of creation. The slow unfolding of creation can offer comfort. When days feel crowded or minds grow restless, the serenity of interstellar space provides a reminder that not all motion needs to be fast. Some processes thrive in quiet. Some structures take shape only when there is room to breathe. The stillness between stars is part of the galaxy's balance, a pause that makes the bright regions possible. In this way, the darkness supports the light, just as rest supports activity in a living being. In a living being, rest is not absence, it is preparation, it is renewal. Interstellar space mirrors this truth. Its vast emptiness is not a void, but a cradle. Its silence is not loneliness, but potential. Its coldness is not harsh, but clarifying. In these qualities, the mind finds a gentle resonance, an opening for quiet reflection. A quiet reflection arises. The universe is not made only of brilliance and heat, but also of deep, patient darkness. Both are necessary, both are beautiful, both shape the paths of stars and the drifting of galaxies. The interstellar medium stands as the calm canvas upon which the brighter elements of the cosmos rest. It is the background breath of the galaxy, slow and steady. Slow and steady, the mind drifts with it now. Thoughts loosen, weight lifts, space opens. The darkness between stars widens into a soft and welcoming room. Here, Nothing presses forward. Nothing demands attention. The silence spreads like a cool cloth across the senses, easing tension, smoothing the edges of the day. And from this soft openness, we drift toward the places where light gathers again, the glowing nurseries where stars bloom within cosmic clouds, unfolding the next chapter in the galaxy's gentle dance. The quiet between the stars stretches wide and cool, but gradually, like a faint colour forming at the edge of night, something begins to appear within the darkness, a mist, a pale veil, a drifting shape touched by the gentlest hint of glow. These are nebulae, the vast clouds of dust and gas that hang in space like soft brush strokes, subtle at first, then deepening in colour as your imagination drifts closer. Within these clouds, the universe prepares its most patient creations. Here, light does not yet shine fiercely, it gathers slowly, as though waking from a long dreamlike rest. From a distance, nebulae often look like shadows, dark, quiet swaths where stars hide behind curtains of dust. But as starlight filters through, or forms within them, these clouds reveal their colours. Some glow with muted reds from hydrogen atoms excited by ultraviolet radiation. Others shimmer with blues scattered from hot young stars. Some radiate soft greens and violets, each hue a sign of different elements warmed to different temperatures. These colours are not loud or sharp. They drift through the cloud like watercolour washes, blending into shapes that resemble slow-moving smoke. Slow-moving smoke curls through regions called molecular clouds, cold, dense pockets where gravity begins its subtle work. Inside these clouds, molecules form, break apart and form again, gradually creating the conditions needed for starbirth. Carbon monoxide, hydrogen, ammonia. Each molecule plays a part in shaping the chill interior of the cloud. Temperatures here can drop close to just a handful of degrees above absolute zero. At such low levels, motion slows, turbulence calms, and the cloud settles into a serene, steady quiet. A serene, steady quiet is exactly what the birth of a star requires. Gravity must gather the gas slowly, gently compressing it over long cascades of time. The cloud thickens in places, forming dense cores where the molecules crowd together. In these cores, pressure increases, heat builds. Eventually, atoms begin to collide frequently enough to ignite fusion. The moment is soft in its beginning, hidden from sight. Heat seeps outward, light flickers dimly, but the surrounding cloud remains thick enough to hide the newborn star within its folds. Only when radiation pushes aside the dust do the first hints of brightness escape. Brightness escapes like a shy spark pressed against a curtain. When the dust thins enough for the star's light to shine through, the nebula surrounding it begins to glow. This is how emission nebulae form, clouds lit from within by the ultraviolet radiation of young, hot stars. The Orion Nebula, visible in a small telescope on a clear winter night, is one of the brightest examples. Deep inside it lies a loose cluster of newborn stars, their combined shine lighting up the gas around them. The nebula glows in delicate reds and pinks, the signature colour of hydrogen giving way to soft gradients. Soft gradients define many nebulae. The Eagle Nebula, home to the famous Pillars of Creation, contains towering structures of dust that rise like ancient stone columns in a slow-moving cosmic breeze. These pillars are sculpted by the radiation and winds from nearby stars, their surfaces etched into ridges and hollows. Inside them, new stars continue to form, protected by the thick walls of dust. The light from these hidden stars will eventually erode the pillars from the outside, revealing the forming clusters within. But for now, the structures stand tall, quiet guardians of an unseen glow. An unseen glow also fills reflection nebulae, clouds that do not shine by their own energy, but reflect the light of nearby stars. These nebulae often appear blue, because blue light scatters more effectively off fine dust particles. The Pleiades star cluster is wrapped in such a cloud, its bright young stars surrounded by delicate swirls of pale blue mist. In images, these reflections look smooth, luminous, and cool, like the glow of moonlight on water. Their appearance is soothing, inviting the mind to drift more deeply into the quiet folds of space. The quiet folds continue into dark nebulae, the most silent of all. These are clouds so dense that they block all light behind them, appearing as black shapes against star-filled regions. They are not voids, but thick blankets of dust and gas, hiding the early stages of star formation within. The Horsehead Nebula, one of the most recognizable dark shapes in the sky, stands as a silhouette against a bright red emission cloud. Its edges are soft, its outlines sculpted by the slow erosion of interstellar winds. Dark nebulae remind us that not all beauty is bright. Some forms exist in shadow, shaped by absence rather than presence. Presence and absence mingle gently across these clouds. The interstellar medium flows into and out of them, feeding their growth or wearing them away over millions of years. Waves of energy from nearby stars push the edges inward. Slow gravitational collapses pull the interiors tighter. Chemical reactions on dust grains form icy coatings that later evaporate in warmer regions. Everywhere within these clouds, small transformations occur with deep patience. Nothing is hurried, nothing is forced. Every movement is softened by the immense timescale on which it unfolds. The immense timescale offers comfort. If stars take millions of years to be born, then there is no urgency in the cosmos. The universe is content to wait for gravity to gather atoms, for dust to settle, for light to find its way through. In this slow, gentle process, the mind can find its own pace softening. Thoughts that once rushed may now stretch, lengthen, and drift, mirroring the gradual bloom of starlight within a nebula. Within a nebula, heat and light follow winding paths. Ultraviolet photons from young stars excite the surrounding gas, causing electrons to jump to higher energy levels and fall back again, releasing light in specific wavelengths. This cycle repeats countless times, weaving colour into the cloud in a soft, steady shimmer. Meanwhile, the dust absorbs warmth and re-radiates it in longer wavelengths, producing a gentle infrared glow. These processes create the layered luminosity seen in astronomical images, bright points where stars shine through, softer patches where light diffuses through dust, dark regions where the cloud remains thick. Thick clouds can take many shapes, each carved by the interplay of light and gravity. Some resemble waves frozen in motion. Some stretch into long filaments that twist like braided smoke. Others form rounded bubbles where stellar winds have cleared space. While telescopes often capture these forms as dramatic silhouettes, in reality they are quiet, slow-changing structures. Their appearance may shift subtly over centuries, but at any moment they rest in a tranquil balance of forces. A tranquil balance also appears in planetary nebulae, the glowing shells of gas thrown off by dying stars. Despite their name, These nebulae have nothing to do with planets. They earned the title because through early telescopes they appeared as small, round disks resembling distant worlds. These nebulae often glow in vibrant greens, blues and reds, their colours determined by the elements within them. As the gas expands, it thins, becoming more transparent. Over thousands of years, the glow fades and the nebula dissolves into the interstellar medium, its material ready to become part of new clouds, new stars, new cycles. New cycles begin quietly within the darkest parts of molecular clouds, where newborn stars first emerge as protostars. These young objects draw in surrounding material, their gravity shaping disks of dust around them. Within those disks, particles begin to stick together, forming the first grains of what might someday become planets. This process is gentle, starting with collisions so soft that they barely disturb the motion of the dust. Over time, these grains grow into pebbles, then rocks, then larger bodies. Here again, patience defines the progression. Worlds take shape grain by grain, layer by layer, orbit by orbit. Orbit by orbit, the newborn stars brighten. As they accumulate mass, their cores heat further until fusion stabilizes into a steady pattern. The stars then begin their long lives, leaving behind the clouds that formed them. What remains of the nebula may disperse, or be shaped into new structures by stellar winds. The region transforms, but traces of its earlier form linger. Faint ripples of gas, clusters of young stars, thin layers of dust illuminated by the glow. Illuminated by the glow of these transformations, nebulae become reminders that creation is not explosive or frantic. It unfolds in slow waves, guided by quiet forces that have acted since the dawn of time. Gas gathers, light grows, and forms shift without haste. The universe takes its time, trusting in the steady pull of gravity and the gentle push of radiation. The gentle push and pull of these forces mirror the motions within a human life, expansions and contractions, seasons of gathering and seasons of release, moments of brightness and stretches of shadow. Just as stars bloom within clouds, ideas bloom slowly in the mind, emerging when calm allows them to take shape. The nebulae, with all their patient processes, show that beauty thrives in slow creation. Slow creation is a soothing truth. It tells us that there is space for rest, for pause, for quiet formation. Nebulae do not rush to reveal themselves. Their colours shift only when light allows. Their shapes change only when forces move them. They exist in a balance that encourages softness. Let these colours soften your thoughts. Let the drifting clouds feel like a blanket, light and cool, settling across the senses. Let the shapes of distant nebulae become places where your mind can wander without effort. In the soft glow of these cosmic cradles, there is room for breath, for ease, for gentle reflection. And as these clouds thin in the imagination, as the glowing forms recede into the larger darkness of space, we follow the newborn stars that step softly from their folds, settling into the long, quiet places where the calm strength of gravity waits to guide their paths. The stars that form within the folds of nebulae do not remain hidden forever. Gradually the clouds release them, letting their light spill outward into space. Each young star settles into its own place, finding balance in the vastness around it. And beneath this settling lies one of the most gentle and enduring forces in the universe: gravity. Gravity does not shout. It does not rush or flare or burn. It moves with quiet purpose, shaping everything from the smallest grain of cosmic dust to the largest clusters of galaxies. To the eye, its work is invisible, yet its influence is everywhere, pulling softly, patiently, and without pause. It is the calm architecture of the universe, a steady guide for every drifting world. A steady guide is what allows planets, moons, stars, and galaxies to follow their long and graceful paths. Gravity curves the fabric of space around massive objects, creating valleys and slopes that everything else moves along. Imagine placing a smooth stone on a soft sheet. The fabric bends subtly beneath it. Now imagine trillions of such stones, some small, some massive, all resting on that same vast sheet. This, in simple form, is what gravity creates. A landscape of curves and dips, gentle and immense, shaping the roots of celestial bodies. Celestial bodies move along these curves with a rhythm that feels almost musical. A planet orbits its star not by forceful tugging, but by falling endlessly around it, always moves forward, always being pulled inward, never quite reaching the centre. This balance between motion and attraction creates orbits that can last for billions of years. The Earth follows such a path around the Sun, never pausing, never drifting away, held by gravity's calm embrace. Gravity's calm embrace extends far beyond our solar system. In tight double-star systems, two suns orbit one another in slow, beautiful arcs. In some cases, one star swells into a giant while its partner pulls gently at its outer layers, exchanging material with a tenderness that belies the vast energies involved. Their motions are predictable, stable, and continuous. Even when one star eventually collapses into a white dwarf or neutron star, the dance can continue. A new rhythm formed by old companions. Old companions also gather into star clusters, groups of stars formed from the same cloud, bound together by their shared gravity. These clusters drift through the galaxy as unified families, slowly losing members over millions of years as gravitational interactions nudge stars toward new paths. The remaining group, though smaller, continues onward, carrying the memory of its formation in the slow orbit of its members. In even larger structures, gravity weaves galaxies into intricate webs. The Milky Way itself is part of a group of galaxies, all moving together in a vast region of space. Some of these galaxies will merge in the distant future, their stars blending into new forms. Such mergers are not violent in the way human senses might imagine. Stars rarely collide directly. Instead, galaxies glide through each other, their shapes distorted, their paths adjusted, but their inner calm largely preserved. Gravity guides this slow dance, ensuring that even large-scale changes unfold in a measured, steady way. A measured, steady way defines how gravity sculpts the environments around stars. Close to the star, gravity holds planets and asteroids in tight orbits. Further away, it forms belts of icy bodies that drift in slow loops. Beyond these, it shapes the boundaries of the star's influence, where the solar wind meets interstellar space. At every distance, gravity provides structure, setting the pace and pattern of motion. Without it, the universe would have no shape, only scattered matter drifting without direction. Direction is what gravity gives to every dust grain that spirals toward a forming star. It gathers the smallest particles into disks around young suns, where collisions and gentle sticking gradually build larger bodies. As these bodies grow, their own gravity increases, drawing in more material. Over time, these small beginnings become planets, moons, or asteroids. Entire worlds take shape through the soft, persistent pull of gravity, responding to its quiet encouragement without resistance. Without resistance, gravitational waves ripple through space when massive objects move, collide, or merge. These waves are incredibly faint, stretching and compressing the fabric of space-time by distances smaller than a proton. Yet instruments on Earth can now detect them, revealing the movements of black holes and neutron stars far across the universe. The waves travel silently, carrying information about events that happened billions of light years away. Even in their faintness, they are gentle reminders of gravity's reach. Gravity's reach extends into the dark matter that permeates the cosmos. Though invisible to telescopes, dark matter exerts gravitational pull, shaping the formation of galaxies and holding them together. Without it, galaxies would spin apart. With it, they maintain their spiral forms and stable rotations. Dark matter does not interact with light, heat, or ordinary matter in familiar ways. It simply rests in place, guiding the structure of the universe with a quiet and unseen hand. A quiet and unseen hand can be the strongest kind, unnoticed until its absence becomes clear. Gravity, in many ways, is exactly that. It does not demand attention. It does not insist on recognition. It simply holds, shapes, and steadies everything that drifts through space. When a star dies, gravity gathers its remains. When a galaxy forms, gravity helps it grow. When a planet circles its sun, gravity keeps the path smooth and consistent. Smooth and consistent is how gravity governs tides on Earth as well. The moon's pull on the ocean creates cycles of rising and falling water, a rhythm that has guided life for billions of years. These tides are not abrupt. They move at a pace so slow that one must watch patiently to see the shift. Yet their influence is profound, shaping coastlines, ecosystems, and patterns of behavior in countless species. Gravity is present in every wave that touches the shore. Gravity is present also in the weight you feel as you rest. It anchors you gently to the earth, giving your body permission to settle, to release tension, to let go. Without it, rest would feel unmoored. With it, the pull offers reassurance, a reminder that you belong to a world that holds you. The same force that shapes galaxies also supports you in this moment, steady and constant. Steady and constant, the universe leans into gravity's guidance. Stars orbit their centers. Planets circle their stars. Galaxies glide through space. Clusters drift toward one another over billions of years. Each motion follows the curves carved by gravity, each path written with calm precision. Nothing is rushed. Nothing is wasted. Every orbit, every spiral, every drift occurs at a pace set by the quiet architecture of space-time. At this pace, the cosmos feels peaceful. What might seem chaotic in a single snapshot becomes harmonious when time stretches wide. Stars form, shine, and fade. Planets gather, drift, and settle. Even black holes with their immense gravity participate in the cosmic balance, helping shape the flow of matter and energy. The universe is not disorderly. It is a slow choreography written in curves and arcs, movements so patient that they invite stillness in anyone who pauses to consider them. Stillness arrives when one realizes that gravity's strength lies not in forcefulness, but in consistency. It is a reminder that stability does not always come from urgency. Sometimes it emerges from subtlety, from enduring presence, from the quiet pull that guides everything gently back into place. Gravity is the universe's soft hand, shaping worlds without urgency, holding stars without constraint, guiding motion without noise. Let yourself settle into this steady pull. Let the calm strength of gravity feel like a grounding presence, a reminder that you are held, supported, and part of a much larger balance. Allow the idea of soft, universal order to ease any remaining tension. Let the arcs and curves of celestial paths become a quiet pattern for the mind to rest upon. And through this steady pull, we drift now toward the worlds shaped by its patience, the silent planets, each moving through space in long, peaceful orbits, carrying ancient stories in their quiet, drifting paths. Planets move through the galaxy with a gentleness that is easy to overlook. From afar they appear small, almost insignificant compared to the vast glow of their parent stars. Yet each one carries its own quiet history, shaped by billions of years of drifting, settling, warming, cooling and changing in slow, deliberate rhythms. They are worlds built from dust and ice and ancient fragments, drawn together by the soft pull of gravity into spheres that glide silently through space. Through space, these worlds follow paths so stable that they seem carved into the fabric of time itself. A planet may circle its star for billions of years without ever straying far from its orbit. This is the peace of celestial motion, a slow, repeating arc that requires no adjustment, no effort, no constant correction. Each world simply continues, held gently in place by the balance of forward motion and gravitational pull. Gravitational pull gave rise to the planets in the first place. In the early days of a star system, long before planets existed, the region around a newborn star was filled with dust and gas left over from the cloud that formed it. These particles drifted and swirled, colliding softly, sticking together, forming clumps that grew bit by bit. Over millions of years, those clumps became bodies large enough for gravity to take over, drawing in more material, shaping themselves into spheres, and clearing paths through the disk of dust. Clearing those paths marked the beginning of distinct worlds. Some formed close to the star, where heat stripped away light gases and left behind dense, rocky planets with iron cores and mineral surfaces. Others formed farther away, where temperatures were colder and lighter elements could accumulate, growing into gas giants with swirling atmospheres. Beyond them still, icy bodies coalesced into frozen worlds, drifting far from the warmth of the central star. Each region produced a different kind of planet, shaped by the environment in which it formed. The environment shapes planets even now. Mercury, closest to the Sun, is a world of stark, quiet extremes, blistering heat on its day side, deep cold on its night side. Venus, wrapped in dense clouds, glows with a pale yellow-white light, its surface hidden beneath a thick blanket of gases. Earth, rich in water and air, carries life across continents that drift slowly over geological time. Mars, with its dusty plains and thin sky, whispers of rivers and lakes long vanished. Jupiter, the giant, swirls with slow-moving storms that have lasted for centuries. Saturn, encircled by delicate rings of ice and rock, drifts like a lantern in the outer dark. Uranus and Neptune glow with deep blues and greens, cold and quiet, far from the sun's warmth. Far from the sun's warmth, the outermost worlds move with even greater stillness. Dwarf planets like Pluto, Eris, and others travel elongated orbits, their paths stretching far into the edge of the solar system. Their surfaces are cold and crystalline, shaped by frost and shadow. Seasons unfold there with incredible slowness. Decades of faint dawn, decades of twilight, decades of night. On these distant worlds, time feels stretched, softened, almost still. Almost still describes many planets beyond our solar system as well. Exoplanets orbit other stars in enormous variety, some close to their suns, circling in days, others far away, taking centuries to complete a single orbit. Some are rocky, like Earth, some are gaseous, like Jupiter, some are ocean worlds with surfaces of endless water, some are barren and dark. There are planets with skies tinted red by their stars, planets where winds sweep across the surface at hundreds of miles per hour, planets covered in ice from pole to pole. Yet no matter how exotic they may be, they all share a certain quiet dignity, the steady, patient motion of worlds that do not hurry. Worlds that do not hurry teach something about calm. The giant planets, with their deep atmospheres, show storms so large they could swallow Earth. Yet these storms move slowly, swirling in graceful ovals, guided by the layered currents beneath them. Jupiter's great red spot has persisted for centuries, not as a violent outburst, but as a stable structure in a deep and ancient atmosphere. Saturn's hexagonal storm at its pole rotates gently, its shape maintained by the balance of winds and the planet's rapid spin. Everywhere on these giants, motion is vast but unhurried, like clouds drifting across an ocean whose surface you cannot see. On rocky worlds, the calm takes different forms. On Mars, dust storms rise quietly, their particles lifted by thin winds that barely stir the surface. On Mercury, mountains cast long shadows across a still landscape untouched by air. On distant exoplanets, tides may freeze oceans into patterned plains, creating landscapes that change only when stellar warmth nudges them. The surfaces of these worlds reflect a long patience, the time it takes for rocks to erode, for craters to form, for thin atmospheres to shift and settle. Shift and settle. This is the rhythm planets follow. Their motions around their stars are predictable, their day-night cycles steady, their seasons tied to the tilt of their axes. Even the variations, wobbles in orbit, changes in tilt, slow cooling of interiors, unfold over spans so long that they feel gentle, not abrupt. Over millions of years, planets reshape themselves from the inside and out, responding to forces that move at the pace of deep time. Deep time gives rise to moons as well, each one silently circling its planet. Earth's moon moves slowly away from our planet each year, drifting outward as tidal forces exchange energy. Jupiter's moons dance in resonance, Io, Europa, and Ganymede, pulling on one another in a rhythm that keeps their orbits stable. Saturn's moons shepherd the edges of rings, guiding the ice particles into narrow shimmering bands. Around distant gas giants, moons may hide oceans beneath icy shells, warmed by tidal forces that stretch and compress them. Each moon moves quietly, shaping and being shaped by its gravitational partners. Gravitational partners create peaceful harmonies. When three bodies orbit in resonance, their periods align in ratios that repeat predictably. A celestial music made not of sound, but of motion. These harmonies help stabilize orbits, keeping worlds from drifting into chaos. Even when orbits shift over time, the changes are slow, allowing systems to evolve gently. Astronomers observe these formations with a sense of awe, recognizing that nature finds equilibrium even in complexity. Equilibrium extends into planetary atmospheres as well. On Earth, air flows in global patterns, balancing heat between equator and poles. On Venus, thick clouds reflect sunlight and trap heat, creating a steady environment beneath their dense shroud. On Titan, Saturn's largest moon, a thick atmosphere of nitrogen and methane circulates in slow waves, shaping lakes of liquid hydrocarbons. Everywhere, the rhythm is measured. Slow winds, long seasons, cycles that repeat without urgency. Cycles without urgency create landscapes shaped not by sudden upheaval, but by steady processes. On Mars, ancient riverbeds remain etched into the surface, slowly filled with dust but still clear in their form. On Earth, continents shift a few centimeters each year, carving mountains and opening oceans over millions of years. On icy moons, cracks form in frozen surfaces as tidal forces tug and release, creating patterns like frost on a window pane. These landscapes evolve with patience, reflecting the calm persistence of the forces that shape them. The calm persistence of planetary motion becomes a soothing thought. If a world can move through space for billions of years without losing its path, if storms can swirl for centuries without breaking apart, if landscapes can form in silence across deep time, then there is comfort in the slowness of these processes. Planets remind us that much of the universe operates at a pace meant for stillness, not haste. Stillness settles in as the mind drifts among these worlds. Picture Jupiter's clouds, soft bands of cream and gold wrapped around the planet like flowing ribbons. Imagine Saturn's rings, millions of ice particles reflecting faint sunlight as they circle in perfect balance. Visualize the dusty plains of Mars, tinted red by iron oxide, stretching into a quiet horizon beneath a thin sky. Think of Neptune's deep blue glow, its atmosphere rippling with gentle winds that move through cold air. Each world is different, but all share that same quiet endurance, a timeless drifting through darkness. Let these distant worlds steady your breath. Let their slow cycles calm the faster turns of thought. Let the steady arcs of their orbits become a soft pattern beneath your senses. Planets do not rush. They do not strain. They do not try to be anything other than what they are. They simply drift, carried by gravity, guided by balance, patient in their paths. Every orbit finds its calm. And from the peace of these worlds, we drift toward the remnants that linger at the edges of star systems, the ancient fragments of ice and dust that carry the memories of cosmic beginnings, whispering softly through the long open dark. Beyond the drifting planets and the calm arcs of their moons, the solar system extends into regions where the light grows faint and the cold deepens. Here, the familiar structures of worlds and orbits give way to something quieter, older, and more spacious. In these far reaches, time stretches into long, silent threads. Comets, dust, and frozen fragments drift through the dark, carrying memories from the earliest days of the solar system. They move with no urgency, held loosely by gravity, shaped by the faint pressure of distant sunlight. Distant sunlight barely reaches them. Photons that left the sun minutes ago arrive weakened, scattered, softened into the faintest touch of warmth. At these distances, temperatures drop low enough for water to freeze solid, for carbon dioxide and methane to rest in crystalline layers, for dust to lie undisturbed for ages. The Kuiper Belt, circling beyond Neptune, is filled with icy bodies that drift through this cold grey realm. Their surfaces record ancient collisions, slow alterations, and long periods of deep quiet. In this deep quiet, comets wait. These icy travellers belong not only to the Kuiper belt but also to the Oort cloud, a vast spherical shell of fragments that envelops the solar system. The Oort cloud stretches so far that a comet at its outer edge may take tens of thousands of years to complete a single orbit. Most will never be seen from Earth. They drift in darkness so complete that even starlight is faint, yet they remain bound to the sun, connected by gravity's nearly invisible thread. An invisible thread pulls a few of these comets inward from time to time. A passing star, a shifting orbit, or a distant gravitational nudge may send one on a long journey toward the inner solar system. The comet begins its descent through the cold, quiet dark, moving slowly at first, then gradually gathering speed as the sun's pull becomes stronger. For centuries, it may inch its way inward, unchanged and untroubled, carrying its ancient ices intact. Carrying ancient ices is what makes comets special. They are fragments of the early solar system, pieces of the primordial cloud from which the sun and planets formed. Their cores contain water, carbon, nitrogen, and organic molecules that date back billions of years. When a comet finally approaches the sun, warmth begins to touch its surface. The ice starts to sublime, turning directly into gas, and dust trapped within the ice is released. A faint atmosphere begins to form around the nucleus, followed by the long, delicate tail that streams out behind it. The delicate tail does not form from motion alone. Sunlight pushes dust and gas particles away, creating two separate structures, a curved, dust-filled tail that glows softly with reflected light, and a straighter bluish ion tail shaped by the solar wind. These tails can stretch for millions of kilometers, yet they are so tenuous that a human could pass through one without noticing. They are like soft whispers of light, drifting behind the comet as it sweeps across the sky. Sweeping across the sky, a bright comet can become a moment of wonder for those who witness it. From Earth, comets appear rarely enough that each one feels like a gift, a visitor from deep time, glowing briefly before returning to the cold beyond. Some comets come back regularly, following predictable paths. Halley's Comet returns every 76 years, reappearing in the sky like a soft echo from the past. Others take centuries or millennia to return. Some never come back at all. Flung out of the solar system by gravitational interactions. Gravitational interactions shape not only comets, but the dust that fills the inner solar system. Dust grains shed from comets drift slowly toward the sun, forming a thin cloud of particles that scatter sunlight. This creates the zodiacal light, a faint, triangular glow visible just before dawn or after sunset in very dark skies. The glow is subtle, so soft it can be mistaken for the first hint of morning or the last trace of twilight. It is light reflected from dust older than recorded history, drifting quietly along the plane of the solar system. Quietly along that plane, meteor streams also form. When Earth orbits through the dusty trail left by a comet, those particles enter the atmosphere and burn brightly as meteors. Most are no larger than grains of sand, yet they streak across the sky as brief, shimmering lines. Even these fleeting moments carry a long history. The dust that burns in a fraction of a second may have drifted for thousands of years before meeting Earth. It glowed once, softly, behind a comet. It glows again now, briefly, before dissolving into the air. Dissolving into the air does not erase its memory. The solar system remembers its beginnings through these small remnants. these leftover pieces that continue to wander. Asteroids in the main belt between Mars and Jupiter move in slow, steady orbits, their shapes sculpted by collisions that happened long ago. Some are rocky, some are metallic, some contain water locked in minerals. They drift with a sense of deep patience, like stones resting at the bottom of a calm river. A calm river is what the outer solar system feels like when imagined in its entirety. Wide, quiet, slow. The orbits of dwarf planets stretch into distant ellipses. The Oort cloud rests far beyond them, more a concept than a place, its boundaries defined by the reach of the sun's gravity rather than any physical marker. Between these structures lies emptiness that is not empty, filled with dust, drifting particles, and the faint wash of cosmic radiation. Cosmic radiation flows evenly here. High-energy particles from the galaxy pass through these regions without interruption, altered only slightly by the solar wind. Dust grains absorb and emit infrared light, warming slightly under the sun's distant glow. Molecules on comet surfaces rearrange, freeze, crack, and reform in slow chemical cycles. Despite the cold, there is movement, tiny, quiet, and enduring. Tiny, quiet movements continue even on the surfaces of comets themselves. As they drift far from the sun, their nuclei remain still and silent, frozen into deep sleep. Crystalline ices shift almost imperceptibly. Dust settles into position. Light from distant stars reflects faintly off their surfaces. Many comets remain untouched for millions of years, their stories preserved exactly as they were when the solar system was young. When these ancient bodies warm again on inward journeys, the transformation is gentle. Jets of gas release as sunlight reaches deeper into the ice. Dust forms halos around the nucleus, expanding outward in slow, graceful puffs. Some particles escape entirely, joining the flow of interplanetary dust. Others settle back onto the surface, creating layered textures like dunes of shadowy frost. The comet brightens but quietly, as though waking from a long rest. The long rest of these bodies provides a comforting lesson. Not everything in the solar system is in constant motion. Some objects wait, some sleep, some drift at the edge of gravity's reach for ages before returning to the warmth of the inner worlds. In these cycles of approach and retreat, there is a deep rhythm, a reminder that even in vast cold darkness there is continuity. Continuity connects planets, comets, asteroids, dust, and the faint remnants of stars, all formed from the same original cloud, all share the same ancient material. The water in comets matches water found on Earth. The dust between planets contains grains older than the sun. The rocks in asteroids hold minerals forged in generations of earlier stars. The solar system is not simply a collection of objects, but a family shaped by shared origins. Shared origins bring a sense of belonging. When the mind wanders through the solar system's quiet outskirts, it touches memories older than language, older than oceans, older than Earth itself. It moves through a space where time is wide and gentle, where ancient fragments drift without concern, where darkness is calm instead of empty. Let the old stories settle around you. Let the drifting fragments soften your thoughts. Allow the slow movement of icy worlds and ancient dust to calm the inner world as well. They have drifted in silence for longer than life has existed on Earth. Their patience is infinite, their motion is soft, their presence is steady. These drifting fragments carry a calm older than memory. And as we follow this ancient river of ice and dust, Carried gently through the open dark, we drift toward a larger stillness, where time itself begins to stretch, slow and unfold in quiet ways, guiding us into the soft rhythms of cosmic time. Time in the universe does not move evenly. It drifts and bends, stretches and contracts, following the quiet shapes carved by gravity and motion. What the clock on your wall measures is only one version of time, familiar, steady, predictable. But out in the cosmos, where space curves around massive stars and galaxies expand like slow-moving tides, time unfolds in softer, stranger rhythms. It becomes something fluid, something wide, something patient. Patient, too, is the light that carries information across the universe. Light always moves at the same speed in empty space, yet the distance it must travel can make moments billions of years old appear in the present. When you look at a galaxy, you see it not as it is today, but as it was when its light began its journey. A journey that may have taken more time than all of human history combined. This alone reveals how differently time behaves beyond Earth. Behaves beyond Earth does not mean chaotic. The rules that shape time dilation, the stretching and slowing of time, are precise, gentle, and consistent. Near a massive object such as a planet, star, or black hole, time passes more slowly than it does farther away. Gravity curves space like a soft indentation, and time flows differently within that curve. It does not lurch or jolt, but eases into its slower rhythm. A slower rhythm appears as well when an object moves quickly. According to relativity, the faster something travels, the more time stretches for it compared to something still. Astronauts aboard the International Space Station experience this effect on a tiny scale. They age just slightly less than those on Earth, but near the speed of light, the effect becomes profound. Time for a fast-moving particle may pass thousands of times slower than it does for a stationary one, yet none of this feels dramatic to the object experiencing it. To that particle, to that astronaut, to that traveller through curved space, time feels normal, steady, continuous. It is only when comparing one reference point to another that the differences appear. Soft and subtle, like ripples moving quietly across a lake, quietly across the cosmos, greater stretches as time unfold. Space itself expands, drawing galaxies away from one another in slow, steady motion. This expansion gently elongates the wavelengths of light travelling through it. What was once bright and energetic becomes stretched into softer, redder hues, a phenomenon called redshift. It is as if the universe is exhaling, and each photon carries the echo of that breath. The echo of that cosmic breath reveals a universe that grows calmer as it ages. In the early moments after the Big Bang, everything was hot, dense, and fast. Particles crashed together, energy surged, matter formed and reformed. But as the universe expanded, its temperature dropped, atoms settled, stars formed, galaxies drifted apart, the pace slowed. Even today, the universe continues this long exhale, stretching time wider with each moment. With each moment, large structures feel the gentleness of this widening. Clusters of galaxies bound by dark matter and gravity drift slowly through expanding space. Inside them, stars orbit their galactic centers in arcs that take hundreds of millions of years. This slow dance of galaxies unfolds in timescale far beyond human perception. Yet these processes do not feel frantic or turbulent. They feel like the universe practicing patience on a scale too vast to fully grasp. Too vast to fully grasp is the environment near a black hole, where gravity grows so strong that time slows dramatically. To a distant observer, An object falling toward a black hole seems to move slower and slower, never quite reaching the event horizon. Time, from that vantage, appears to almost freeze. Yet for the object itself, the fall would continue normally. This contrast shows how flexible time can be, how deeply tied it is to the shape of space and the pull of gravity. The pull of gravity shapes time in smaller ways as well. At sea level on Earth, time passes slightly slower than it does at the top of a mountain because the gravitational field is stronger closer to the planet's center. The difference is tiny, measurable only with extremely precise clocks. But it exists. Even our daily experience unfolds within gradients of time, though we never feel them directly. Never feeling these variations does not make them any less real. Instead, it makes them soothing, like hidden truths that reshape the world quietly. Time's flexibility is part of the universe's calm structure. Not something to fear, but something to appreciate. It allows light to travel across expanding space. It allows galaxies to drift. It allows matter to gather, collapse, and form new stars. It gives the cosmos room to breathe. Room to breathe is something the universe extends generously. As space expands, distances grow between galaxies, and the overall tempo of cosmic evolution slows. Stars form more gradually. Interactions become rarer. Heat dissipates. Light stretches. This does not mean the universe becomes empty or quiet in a lonely sense. Rather, it becomes spacious, a vast landscape of tranquility where processes unfold at a pace set by the softness of physical laws. That softness appears even in the most energetic events. Supernovae, explosions that release immense energy, glow brightly for weeks or months, then fade into the background. The remnants expand for thousands of years, slowing over time, eventually dispersing into the interstellar medium. What begins in sudden brightness ends in gentle dispersal, contributing to new cycles of creation. Even violence in the cosmos ultimately flows into calmness. Calmness deepens when we consider that time will continue to stretch as the universe evolves. In the far future, trillions of years from now, stars will grow rarer. Galaxies may drift out of view as space expands faster. Time itself may elongate to the point where events that once happened regularly become exceedingly rare. This distant era is not one of fear or loss, but one of cosmic rest, where the universe reclines into a slower rhythm. A slower rhythm is something the mind can adopt while imagining this gentle future. There is reassurance in knowing that the universe itself values patience. Nothing in its vast expanse insists on haste. Even the flow of time follows paths shaped by gravity and motion, adapting its tempo to the environment. It is a reminder that stillness is natural, not an interruption, but a mode of existence written into the structure of reality. Let your sense of time loosen. Allow thoughts that cling tightly to schedule or pace to soften. Let the slow drift of galaxies guide your breath. Feel the quiet expansion mirrored in the gentle widening of the chest during inhalation. Let time be a spacious thing, not a narrow one. There is no hurry in this wide dark. And if you're still drifting with me, your body already knows this quiet rhythm, the calm unfolding of moments without pressure. Time stretches softly around you. Thoughts wander without direction. The universe expands, and with it, the mind opens gently into wider awareness. As this stretched time settles, we drift toward our final, quiet return, back to the body, back to the breath, back to the familiar world resting beneath your own sleeping sky. You've travelled through silence and science tonight, drifting from the soft birth of stars to the long breath of cosmic time. The universe has unfolded slowly around you, light blooming in nebulae, planets circling in patient arcs, comets carrying ancient memory, and time itself stretching into wide, gentle rhythms. Now, the journey bends inward again, returning you to the quiet place where your body rests. Nothing rushes here. Nothing pulls you forward. This final drift is only a settling, a slow and welcoming descent. A slow and welcoming descent feels like a return to warmth after wandering through the cool expanse of space. The room around you may be dim, the blankets soft, the air still. Your breath has found a calmer rhythm, shaped by distant galaxies and star-filled stillness. The cosmos has a way of placing everything into perspective, its vastness stretching wide enough to hold every thought, every feeling, every moment without strain. And now that vastness narrows gently, not closing, but focusing, settling like dusk at the edge of the mind. At the edge of the mind, the images of the cosmos still linger, nebulae glowing with soft colour, silent planets drifting along their ancient paths, dust grains shimmering in faint starlight. These visions remain, not to fill the mind with noise, but to soothe it. They remind you that the universe moves slowly, carefully, and without hurry. And in that reminder lies an invitation that you too can move softly, breathe gently, and rest without expectation. Without expectation, the body grows heavier in the most comforting way. Shoulders loosen, muscles soften. The world becomes quieter. Awareness drifts inward, then outward, then settles somewhere in between, floating lightly, supported by the simple fact of being here. You do not need to hold anything. You do not need to think your way through the night. The calm you've gathered along this cosmic journey rests beneath your breath like an anchor that does not weigh you down but steadies you. The universe holds its stars in wide spirals, and your breath holds you in a slower, smaller, but equally meaningful rhythm. As you drift, you might sense the echo of cosmic motion within your own stillness, how your inhale expands like space itself, how your exhale settles like dust returning to rest. You're not separate from the universe you've explored. You're part of it, shaped by the same laws, held by the same quiet gravity. Quiet gravity settles around you now. The weight of blankets, the softness beneath your body, the familiar scent of the room, the subtle warmth along your skin. These sensations draw you back gently without urgency. Even as your awareness returns, the calm remains. The cosmos has shared its patience with you, its slow breathing, its endless ease. You carry that now, woven into your own sense of rest. A sense of rest that deepens with each passing moment. You may be drifting on the edge of sleep, or you may still be awake, wandering in the soft haze between thought and dream. Either way is perfect. Night does not demand anything of you. It simply offers space. Space to settle, to soften, to drift into whatever form of rest your body chooses. If you're still here, your body already knows what peace feels like. The slow rhythm of galaxies has become the slow rhythm of breath. The expansion of time has become the deepening of quiet. The drifting of planets has become the drifting of thought. Everything that felt far away now feels close, gentle, and familiar. Familiar too is the earth beneath you, the steady ground that carried you long before tonight's journey. You return to it now with softened senses, feeling its presence beneath the layers of fabric and air and stillness. The planet itself drifts through space with the same calm you've explored. It moves in silence, wrapped in atmosphere and shadow, carrying oceans, forests, mountains, and the quiet places where life rests. You are part of that rest now. Now the night folds itself around you with a softness that echoes the glow of distant nebulae. The world grows quiet. Thoughts loosen their shape. Breath becomes slower, smoother, almost weightless. There is nothing left to do, nothing left to solve. Only this settling, like dust drifting back to the surface of a comet after a long journey through sunlight. The night settles. Your breath softens. The world grows quiet around you. Thank you for sharing this quiet space with me. Good night.